Good morning, ladies and gentlemen. Welcome back. Today is, I think, Thursday, April 23rd. Been having some technical difficulties. I'm trying to upload this lesson on exponential functions. Hopefully, it'll be short enough to talk about what we need to know about exponent rules and rational exponents. Hopefully, you got a chance to look at the handouts that were provided on the Google Classroom. Let's just get to it. What you see hopefully on the screen is the grade 9 material that you've already learned about the exponent rules. Just going to go through them quickly. The law of multiplication is when you have same base exponents, you can add the exponents. When you're dividing same base exponents, you can subtract the exponents. If we raise a power to the exponent, we can multiply their exponents. Zero exponent rule is anything to the zero is equal to 1. Keep in mind, 0 to the 0 is indeterminate. Negative exponents, of course, represents a fraction, a rational number. So it's 1 over x to the n. And finally, the power of product and the power of a quotient. When we have a base that's being raised to an exponent, you can actually distribute it across the numerator and denominator, for example, the power quotient. So what we're going to be doing really quickly, hopefully you got a chance to look at some of these questions. Question number 1, Evaluate without using calculator. These are pretty straightforward. Let's just take a look at question E. Let me just zoom in really closely. For some reason, hope that's okay. Let's check question E. Really straightforward. 3 to the n divided by 3 to 3x. 3 to the n divided by 3 to the 3 times 3 to the 6. And what we got is, hopefully my pen is going to work. There's many ways of actually doing this, right? But most of you will do it this way. Notice I didn't use a calculator, and that's why we use simplification first before evaluating. Notice I added the denominators because 3 plus 6 is the same basis. And that's the answer for question E. So question 2 is pretty straightforward as well. I think you're okay with that. Let's just maybe do question 2D. Notice when dividing, we subtract, right? So -5 plus -2 is -7. -7 minus -8 is 1. So we rewrote the expression as a single power. All right, so that's all pretty straightforward. The new concept that we're going to try to get through today for this small part of the video is understanding that a rational exponent is actually a square root. And so that's what we're trying to discuss first. In fact, the very first square root that we talked about way back in, I think, October, is that the root function, or square root, that is the first one. And the reason why, if you take a look at the symbol, there's actually the 2 there. So that's how you say that, square root. But what we're trying to establish now is that it is analogous, or it's actually equivalent to x to the 1/2. Most students find this particular rule easier to remember, and I'll just write it out. X to the m over n. Notice that's a fractional exponent. The m is the numerator, the n is the denominator, and look where the n is going to go when we write it as a radical. The n is going to go right there. That's the nth root of x to the m. Another way to rewrite that is the nth root of x all to the m. So notice where the denominator is going to go into the root sign. Let's practice question 1 together. Write each of the following in radical form. Let's try question 1a. That's 7 to the half. So I think a lot of you understand what we're going to do. The 7 is going to go underneath the radical sign, and the 2 is actually there. Now we don't have to write it in, because that is actually the first one. So the way that you say this is square root of 7. How about question C? I think everyone's okay with that. We're just rewriting it to radical form. The 8 goes under the radical sign, and the 5 is going here, and I'm going to put the 2 there. How would you say this? I'm going to write this out in quotes. It's the 5th root of 8 squared. So that's how you say that. Let's try question 2a. Notice this is the 7th root of 8. And how would we write that? Well, again, most of you get the base correct. The base is going to be 8. What's the exponent? Well, that 8 in the question has an exponent of 1. So I think everyone's okay with this. This answer is 8 to the 1/7. Let's try question C. Question C is 1 over the square root of 4 cubed. Now let's deal with that 1 over really quickly. And, or maybe some of you might do it this way. 1 over, and I think that's a square root of 4 cubed. So I think everyone's okay by translating that. The M, as in Mary, is the 3. The N, as in Nancy, is the 2. We're not done yet. Hopefully, you remember the negative exponent is a fraction. So that's a translation of what we're doing for question 2C. Now, I'm actually not proficient in working with radicals. I actually do not like radicals, and I tend to use the power rule. Let's just go scroll up. It will scroll up for me. I tend to use the power rule a lot when teaching this particular unit, just for this first part. And again, take your time. Feel free to look at your notes, your textbook, the CEMC resources if you need some help. So I'm going to just do 2 more, and then I think that's going to be it. Again, you're trying to do these without a calculator, and some of you know with the Sharp EL510RN calculator, there is a square root sign and there is a y to the x button. I mean, it's okay to double check your work, but what we're trying to get you to do is try to solve things by using the exponent rules or exponent laws. Let's take a look at question 3e. Now, question 3e is 27 to the 1/3. And again, I'm going to write this off to the side. This question is really the cube root of 27. And some of you are fine by actually answering this without a calculator because you actually understand that the cube root really means a repeated multiplication that goes under the radical sign how many times. However, I actually like using this understanding by changing the 27, the base, into a power that I can manipulate. Now, 27, believe it or not, is 3 to the 3. Let's pause there for a second. That is the base. That is the same thing as 27. But notice, let's change the color here. That's to the 1/3. And so when we actually multiply, because the power rule says we can multiply those exponents, the 3 and the 1/3, we get actually 3 to the 1. And that is the answer. That is actually the answer for this question. That is 3. Let's try another one. Let's try question L. L is 32 to the 2/5. Again, the trick for this, or the hint that I like showing my students, is that some students don't know how to rewrite the base into an equivalent power. Well, the n of the fractional exponent, or in this case, the 5, is kind of giving you a hint. Now, don't feel bad if you have to check with your calculator, but 32 can be rewritten as 2 to the 5. 2 to the 5 all to the 2/5. Notice 5 times 2/5, making sure you know how to multiply fractions, is simply 2. So then the final answer, and this is bad math, that's going to be 4. Notice, I did not need to take the 5th root of 32, although some of you can, and then square it. So those are just a couple examples from question 3. Oh, we'll do one more. Let's try question Q. Question Q is 4 squared times 4 to the negative 3/2. Now, the way that I would do this question is change that exponent of 2 to 4 over 2. And the reason why is because when we have same bases, and we're really going to add the 2 and that -3 halves, a lot of you remember that it's actually easier to get a common denominator. So 4 halves plus -3 halves is 4 to the half. And again, this one's actually pretty easy if you use square root. But again, I feel like that's just a practice to make sure you understand what I'm trying to show you. Don't get me wrong, over here, and I'll write this in blue. At this stage, don't feel bad if you're doing it like this. But a lot of you know what I'm trying to show you, hopefully, is that this answer is going to be 2. So that's the answer for this question. So now we get to the more interesting questions, and we'll just do one. Question 4, definitely try to use your calculator. And the button that I think most of you are going to use is y to the x, or the above it. And I can't remember the syntax because I don't have my calculator with me. I have a different calculator home. There's a button above. I think it says y like this. I could be wrong. And the y is actually supposed to go inside there. They just didn't show it. So now we're just doing this with the algebra. And let's just try question H. And this will be our last one. So question H is x to the 5/6 times x to the 2/3 all divided by x to the half. So I think they're just trying to get you guys to manipulate the fractions. So let's just do that right now. That's 4/6. So we're going to add, subtract 3/6. So what is the answer? 5 plus 4 is 9. 9 minus 3, 6. And that's the answer. So hopefully that helped a little bit. And I'm going to probably do another video on lesson 6 that I like doing next. I think these are all the answers. Hopefully I got them right. This is, I think, my third take of the video. I was having some audio issues or the screen. So again, hopefully this video is going to work. I'm going to upload it now, hopefully, and it will be all right. As always, feel free to email me if you have any questions, or if you want me to do a particular question, and I'll add up another video in a moment, or hopefully soon. Take care.